What's up, Reef Builders? Welcome back to another episode of the Reef Therapy Podcast. This is episode 135. I'm here with the owner of Oceamo, Christoph Denk. And how are you doing today, Christoph? Thanks for coming on.
Hi everyone, thanks for having me, Salem. Yeah, I'm good. It's already quite late here, so it's already dark outside. But feels still feeling good for doing this here. Very excited to be on Reef Builders.
Yeah, we've got some very exciting news. Some people might have seen it, but I figured it was very worthy of having you on to discuss it in depth. So why don't you share with the world what you've got new?
Yeah, sure. We've got. Most people know us for conducting ICP analysis. I'm a chemist, and we're doing this for a few years now, and we did a lot in trace element work with ICP-MS, but we've always been blind on the organic side of things. And as you know, organic chemicals, this is a very wide range of different compounds, ranging from toxins to amino acids and vitamins, and a lot of environmental contaminants and so on. And it always bugged me a bit that we can't measure them in the reef tank. And at the same time, there's often like the cases where, the ICP is perfect and the setup of the reef tank is perfect in terms of flow and lighting and everything's good. But the reef tank is still suffering or showing some symptoms of toxicology, or there is some fish die-offs or some unexplained tissue loss or whatever, yeah? And there were only basically two fields that could be wrong. It's like the biology or the organic chemistry. And this is why we started the Organo-MS. It's a new type of lab test that can specifically test for this organic compounds.
So why don't you, for people that are just completely unknown with chemistry, why don't you walk through some of the things that you're testing and why those are important?
Okay, sure. Inorganic chemistry, that's more or less the opposite. It's like all the elements, the copper, the molybdenum, the iodine, those elements that are tested in the ICP test. And organic compounds are mainly organic stuff that is built up of carbon and hydrogen and some other elements. And those are connected in different ways. And by connecting them, it's like a huge puzzle, and you can combine those carbons and hydrogens, like nitrogens, in different ways, and can end up with very different compounds, with very different profiles, like important medications or very dangerous toxins at the same time. And to just give you some examples that matter for us in the reef keeping world, there is in sunscreen products, there is this chemical or organic UV filters. You apply them on the skin, and those molecules are just absorbing light from the sun to protect your skin. And those organic light filters, they are banned from the state of Hawaii, and I think from different areas that have natural reefs out there, because it has been shown that those compounds are dangerous to the reefs, to the coral. And when there is a lot of people swimming around near the reefs and snorkeling, those compounds just end up in the water and are toxic to coral. And this is, for example, a class we are testing for. There is a bunch of potentially dangerous UV filters, and we are specifically monitoring for those. Then another example is paletoxin.
This is That's a cool one.
That's a cool one, yeah, and it's a very difficult one to measure because paletoxin is a very huge structure. It's like compared to the sunscreens, it's like maybe 15 times as big, from the chemical standpoint, and it's one of the most toxic compounds that is known to man. And it's, I think, quite interesting that the most toxic compounds is not something that that humanity made up. Like all the really potent toxins are like natural compounds, basically. And it's the same with the paletoxin. It's secreted by some dinoflagellates, like Ostreopsis and related species can secrete paletoxin or closely related compounds. And it's also the paletoa, how to say it in English, how to name this paletoas. They are slantids.
Yes.
Yeah, exactly. And many people have them in the tank, and not all of them know that those are really highly toxic. And so this pelitoxin, there has been some hospitalizations because of this toxin, and this is why we monitor it in the water column if there is any, elevated levels of pelitoxin. And then there is this broad range of pesticides and herbicides, which are basically compounds that kill bugs or kill weeds. And what I've heard from Andre, from Reef Moonshiner, is that in his area there is like trucks driving around and they spray for mosquitoes to limit the population of mosquitoes. And I guess this might also be the case in Florida or in other more of the humid states, that there is a lot of pesticides just sprayed around, or those compounds are used in agriculture, but those are also used as household things, like for flea medication for your dog or for your cat, or to eradicate any bugs you have in the house. And usually those compounds are not very toxic to man or to warm-blooded animals, but they have very, very high toxicity towards fish and very high toxicity towards coral as well. Especially the herbicides, they target photosynthesis in many cases. Our corals love to do photosynthesis, so it's not such a good match. And there is hundreds of different compounds, and we try to measure as many of those as possible. And I'm quite sure that these pesticides are often the cause of unexplained fish losses.
Yeah, I know a lot of people that bring in outside air from a protein skimmer to help with their pH. And like you said, with what Andre's experienced, at least here in Colorado, your neighbor might be spraying their weeds. They might have insecticides they're spraying in the air. There might be agriculture near where you live. And all of those are a variable which could affect someone's reef tank. And until now, we had no way to test for them, it's very exciting, because when I first learned of this test, I was so pumped, because it's everything that I've wanted to enter the market as like a fever dream of mine since I worked with organic chemistry, like analytical equipment in college. I was like, what if consumers had this? What if we could test? It's all here now.
It's great, Salem. We make your fever dream come true.
Yes, you have.
Very happy for that.
And I think so. One of the stories that you all had already shared was intriguing to me. So there was someone that had their fish and they had unexplained fish loss, and then the test came back positive for testosterone after they used testosterone cream to raise their levels. So it's like,
exactly. I wasn't really aware that testosterone is really that toxic to fish, but seems to be. And like this we don't actually we don't have testosterone. We don't look actively for testosterone. So this just popped up like as a random find, because we have some of this around 150 compounds at the moment we specifically test for, and then there is like 100,000 of other compounds that might be there, and if they are there, we might recognize them and can still report them in the course of your analysis. And this testosterone was one of them. And I also wasn't aware that those steroids are often applied like as a topical cream. It's like not a shot or a pill or something. It's just a cream you apply, and afterwards, if you touch your water or do some maintenance in the tank, there is the potential, of course, that those chemicals enter into the water and have some side effects. And that's an interesting point with Organo-MS, that we often see the medications that people are using, because there is always some transfer between the reef keeper and the reef. And those things, it's always told you should wash your hand before doing some work in the tank, or you should wear gloves. But this was always anecdotal, and there was never any data to support this. And now we have the data.
Yeah, one of my buddies, his name is Joseph Goucher. He has some of the nicest acropore I've ever seen, but he is the most anal person ever. Like, he only wears sleeve-length gloves. He came to a trade show, and if you bought coral from him, he put on a new pair of gloves to take it out of his frag tank even. And I was always like, he's a little too anal, but with that opening my eyes, maybe not. I think they're really is something behind wearing gloves.
Yeah, I think you must be careful not to enter the stage where it's not fun anymore, because you
Yeah.
just have too much hygiene measures to deal with, and like the hygiene is the primary part, and then the secondary part is the reef keeping. So no, but it's just when you apply some medications, when you apply some sunscreen, even if that's a few days ago, just to remind yourself, and wash your hands or wear gloves, and just be aware of this possibility.
Yeah, so I mean, this really, I think, lets us see the chemical dark matter of a reef tank. I think is a good way to put it. So variables of what's on your hand, variables of what's in the air might be coming into the air, and then I think another interesting thing we talked about before the show, and if you don't have to talk about it if you don't want to, but
Okay,
very unknown variables in many products on the market, to where we could
sure.
be inadvertently dosing things in our tanks that are not claimed on the labels, so to speak.
Sure, that's one point, that there is many products where people are not really sure what's in there, and now those like hidden ingredients can basically can be surfaced, and there is not really any secrets anymore. So I think this will be a huge an important factor for the industry to involve, like out of this playing hide and seek, basically putting some antibiotics in cyano medications and telling at the same time there is no antibiotics in there. So no, usually there is antibiotics in there, and we now can show and prove it. And I mean, it's not just, I mean, this is fraudulent, basically putting something in there and saying it's not in there. I mean, this is something that's a no-go at all. But there might be also side products people are not aware of, even the manufacturer. For example, if you're doing some equipment, and you're having your plastic surrounding your plastic housing of the equipment, and those plastics leach plasticizers. And there was no way of manufacturers to check, okay, what is the level of plasticizers or of, unwanted plastic additives that are in there that might leach into the water. So this is generating a lot of, additional safety or product safety, because those things can be checked. And manufacturers can also, react to these findings and like change the product in a better way.
Yeah, hopefully, I mean, it leads to higher quality control for many of the pumps and things like that, switching to a higher grade plastic, and that benefits the consumer and the animals at the end. That would be the optimistic angle of how this all plays out, for sure.
Yeah, I guess that's beneficial for everyone. It's beneficial for the manufacturers to produce better products, and to have peace of mind, basically. And it's better for the customer to have the more healthy reef tank in the end. Yeah. And another aspect is, I mean, we're dosing many products like vitamins and amino acids in a reef tank, but there is absolutely no way to measure the levels of those compounds in the reef tank. We can't really compare, okay, how is the amino acid level in a reef tank compared to the amino acid level in natural water somewhere in a coral reef? Or how does dosing of amino acids, how does it affect the concentration in my tank? And what's the concentration of the individual amino acid? Is there some acids that that appear in higher concentration in the reef tank compared to the nature situation? So there is a lot of questions to ask and a lot to learn. And I mean, we're collecting this data now, but having really the take-home messages regarding like those amino acids, this will take a lot of tests to really find the statistics and to get things into correlation.
Yeah, I'm glad that there is finally becoming a way through a community science effort, essentially, to actually quantify and dial these things in, because for so long people have relied on the manufacturers, directions, and they're just simply a shot in the dark. I mean, there's not really a lot of science or testing behind these things. They just 1 mil per gallon, and they throw it on there arbitrarily.
Sure.
And other people go and they make their tanks turn green, and they like what it looks like, but in reality, it's fueling a microbial war, which
Yeah,
the corals are at. So it's cool to dial that into a natural level or find out what those ideal levels are.
yeah, but that's really a longer term process, I guess. Yeah, so that's nothing that's. I mean, we've been doing it for a while now, but still there's not enough data to really, have very solid answers to those questions.
What matters is that the questions are beginning to be answered, though. Before, there was no baseline, no database, no real effort to begin to find the optimal value of these things. And even if the answer can't, or the answer can't be found in like the next 5 years, even maybe in the next 10 it can, and that can be very important, not just for reef tanks, but for any types of conservation research as well. Any of the coral gene banks with the endangered species. I see this going beyond just the hobby for sure.
Mm-hmm. Yeah, I think so as well. Yeah.
Yeah, so why don't you show us one of the reports so people can see hands-on what they might be getting if they send in one of these tests?
Sure. Let's see if this works. So yeah, this is an example report, but it's already like an older one. So in the meanwhile, there is quite many compounds added in addition to this. And we have two main parts on the analysis report. The first one is the so-called targeted analysis. In the targeted analysis, we have like standard compounds. So we have this compound in the pure form in the lab to measure it, to make like a calibration curve, and to really be sure this compound is in there and to give a certain quantity of this compound. So we can really tell you, okay, there is 0.04 microgram per liter of this compound in your tank. And we start here with the vitamins like riboflavin, cyankobalamin, pyridoxine, and nicotinic acid. Those are the B vitamins where people report quite positive effects of corals when you dose them. But to me, it's not really clear how this effect is happening. Then the amino acids. I mean, we measure meanwhile nearly all of the proteinogenic amino acids, like those that are building enzymes and proteins. And the good thing is that there is some data on the natural distribution of those amino acids. So the ideal value we are giving here is like the typical natural concentration that is found for these free amino acids. And what we've seen so far, this has been mostly European tanks and not so many from North America, that the typical concentration in a reef tank is usually lower compared to the natural situation.
I suspect it'll be much higher with American tanks.
Yeah, let's see. There's going to be interesting statistics.
For sure.
Now let's move into the area of herbicides. I mean, many of those are quite common chemicals in agriculture and also like in gardening to get rid of some weeds or to get rid of plants in general. And many of them, like diuron or monolinuron, they're really known to be dangerous for coral. So the ideal value, of course, is here that we can't detect them, because the moment we detect them, it's likely already too much. So having all this NN for, it's like German, nicht nachweisbar, it's non-detectable in English. This is actually a good thing, having those things like non-detected. Then we move into pesticides. Again, this list is like expanded nearly every week. Like last week, we added another 35 pesticides to this list that we're doing the targeted analysis with. And in this tank, there has been a very low concentration of methiocarb found. I mean, this is really difficult to explain where it could be from. The most likely source in my eyes, if it's not like from the skimmer and from the air, like from that somebody was spraying or using this around you, is that it's in food products, because fish feeds have some plant consist of some plants usually as well, and you don't know where those plants are coming from, and you don't know if any pesticides have been used in production of these plants. And even if there's a little bit in there, we're still finding it, because most of those are really sensitive to measure.
Interesting.
Then here we move into antibiotics. I mean, here at the moment we have Cipro and metronidazole. You can see here, this is very high levels of ciprofloxacin and metronidazole. So this customer was actually using those medications to treat his corals because he had some bacterial issue in the tank. So we have this really high numbers, and this is another benefit of this analysis. You can, for the first time, really see how long those compounds stay in the water and how well they are removed by skimming, or how well they are removed by granular activated carbon or by ozonization or whatever. So this way you can refine your dosing schedules or medication schedules to be sure to have a therapeutic level of a certain medication for a certain amount of time in the water.
That's interesting. There's always been a debate about how fast that Cipro and other types of fluoroquinolones, for instance, can degrade in salt water with the use of, there was even some arguments that the near UV, emitted by most LEDs would break them down. But with things like this, potentially not.
No, with Cipro, we've seen it has quite a long residency in the water with the metronidazole as well. I mean, both are bound by activated carbon. We've seen this, and it's known that ciprofloxacin is light sensitive. So having a UVC clarifier in the system, I think it will break it down rather quickly. But having the UVA from the lighting, I mean, this is really low intensity, and also the water absorbs to some point. So I wouldn't expect a lot of degradation because of the normal lighting. But those are really things where you can set up nice studies or mini studies to have like an experiment with 10, 20 samples, like taken in a very wise way, to find out about those effects. Yeah,
you're giving me a lot of ideas. That's all I'm thinking about is experiments to run.
Yeah, for sure. I mean, it's the same with us. There is so much to explore. There is this interesting structural class of dinoflagellate toxins.
Oh,
There is
yes.
so much structural diversity and so interesting compounds, but it's very hard because you don't get any references for this. Those are, how they look like, how yesotoxin looks like, but you can't buy it because it's so very difficult to produce. So you can't get references, but you can still look for it. Looking at other pharmaceutical residues, I mean, we have chloroquine, we have diclofenac, which is often, it's like a pain medication that's used quite often, and it can be really disastrous to ecosystems. So in India, there's been like massive bird die-offs because of diclofenac. Then fenbendazole is a common dewormer. Fluconazole it's like a medication against fungi, basically, but it's used against algae in the reef tank. Would be really interesting story how somebody found out this helps against bryopsis. Then praziquantel, it's like a common dewormer. Then plasticizers, those are compounds that are added to plastics to make them more flexible. And we usually find some of those in every reef tank because everybody has some tubing and some plastic pump housings, and those are the places to look for the sources of these phthalates. And they can act as like neuroendocrine disruptors, so they can mess with the hormone system, which might be a bad thing when you're into breeding, that there is some effects because of this endocrine disruptors. But usually at these low levels we encounter in tanks, my feeling so far is it's not really concerning. Then there is the environmental contaminants. That's an interesting one, the 6-PPD. This is a constituent in tires. So this is like 2 to 3% in tires to make them more resistant. And when this is released into the environment, it can react with ozone to form the 6-PPD quinone. And this is one of the most fish toxic compound that is known. So very, very bad if it enters like your pond, for example. And you can use this analysis not only for the marine tank, you can use it for your koi pond. You could use it for your freshwater tank. So this is very universal in the type of aquatic environment you can use it. Then there is some preservatives. We have PFAS, forever chemicals. And an interesting part is the so-called non-targeted screening, where we look for compounds, we didn't expect firsthand, but they showed up in the course of the analysis. And like with this tank, we've seen there was some ciprofloxacin dosed, and we also find an impurity of ciprofloxacin, which was likely like an impurity in the ciprofloxacin that has been used. We got other plasticizers. We get clindamycin, that's an antibiotic that was not on the targeted analysis, but was dosed as well by the user. So we found it, and we also found some degradation products of metronidazole. And the interesting thing is that even those metabolites of the metronidazole are still pharmaceutically active. So even if the metronidazole is broken down completely, there is still this metabolite that can act as an anti-protozoic medication. Yeah, and that's basically it. Usually there is some interpretation from my side, because without any background information, this data is really difficult to interpret. So I'm always, adding some sentences to make the results usable for the aquarist.
Okay, so let's start. I've got a lot of questions. So, so with the amino acids, your set points, I'm assuming obviously a literature search for that, looking at existing values found on reefs. Can you speak to the regions where those reefs were? For instance, like, is it Indonesia, Australia, things like that? Did you find variability between regions?
It's very difficult finding data.
Yeah.
Because there is only I think I found 2 publications that really report individual amino acid levels, because it's been very difficult to measure those very low levels of amino acids in seawater. That's really a challenging task, and we also developed like an in-house protocol to measure those amino acids. So this is nothing basically out of the shelves. And I think that this publication where I took the reference values from was from Australia, but I'm not 100% sure.
That'd be interesting. I need to go dive and take samples. I bet different reefs would have different amino acid values. So like, one's closer to a river mouth, for instance, things like that.
Yeah, and also with water temperature, because it's very likely that also like heat stress and different environmental conditions will likely also influence this amino acid distribution.
True. So this is something that's ever growing and expanding. So as you find new compounds of interest in the non-targeted, do you plan to then create a curve and add them, if possible, to the targeted section?
Exactly. Yeah. If some compounds pop up more and more, and the standard is commercially available, we can measure the calibration and add it like to the targeted section, of course. Yeah.
So what are go ahead, sorry, I didn't interrupt you.
Yeah, there was one, like it's an Austrian reef tank, a really nice SBS tank. And Florian, hello if you're listening to this. And we sampled his water for the Organo-MS, and there was next to no contaminants in the non-targeted. I think there was only 2 compounds we found, so very, very clean. But one of those compounds we found was saxitoxin. And I wasn't aware of saxitoxin before. So I was looking up the Wikipedia article, and it's also one of the really highly toxic compounds that's secreted by the dinoflagellates, by certain genera of dinoflagellates. And it's so toxic, it was even considered to be used as a chemical weapon like in the 60s or 70s. So that's a really badass compound. And we found it in this really nice reef tank. And yeah, but to recommend in such cases, and I just recommended, lucky that the level is not very high, so just run some carbon, for safety, because those get likely absorbed. But it was really interesting find, yeah.
Yeah, that was going to be my next question. Is in terms of removal, you brought up the instance of how ozone can break it down into actually a toxic byproduct. So do you think that absorption rather than chemically breaking things apart would be the preferable strategy?
I guess so, because when ozone is reacting with something like with the 6-PPD, you would even end up with a more toxic compound. I mean, you need that's a bit of an exotic case, because usually when you ozonize something, it breaks down into pieces, and those pieces are likely not so dangerous at all. But in certain cases, it's possible that you even increase the toxicity by ozonization. Yeah.
I guess UV sterilization would do the same thing. I assume it's a similar process of just shunting larger molecules apart.
Yeah, I mean UV ozone has much more of the tendency. UV is much better for killing like bacteria and for killing microorganisms, while ozone is much better for reducing or for changing chemical structures.
Yeah. So you think probably granular activated or maybe catalytic, any coconut shell based larger pore type carbon would be preferable here.
Exactly, yeah, but you always need to be aware that every adsorber has also some side effects. So I'm not a huge fan of just putting carbon like in every reef tank when there is no reason to do so.
True.
Because with the carbon you're also extracting trace elements. You're also extracting amino acids. You're extracting vitamins. You're introducing a lot of silicon. You might be introducing some phosphorus. So there's always a lot of bypass activity of like every adsorber or every stuff you add to the reef tank. There is not just it not just acts the way you want it to act. There is always something else.
Yeah, everything's a tool with trade-offs for sure. Absolutely. Just trying to find the one with the least amount of trade-offs, I guess. So absorbers seem to be it at this moment, I suppose, for this side of things.
I mean, if you find the sexy toxin, I think it's very well justified to add some carbon. Yeah,
Yeah.
Really depends on the situation.
So that's oh, go ahead. Sorry.
Should I stay with the screen share, or should I switch over again?
Oh, it's totally up to you. You can switch away if you'd like to, or if you have anything else you want to share, we can. Do you have any of the tests? I guess how maybe running through some of the sampling, like do you filter the sample, things of that nature?
Yeah, I mean, I don't have a video with me right now, but you can. It's fairly simple. It's like an ICP test kit, but it's with a different sample container. This is one that has very low leachables, because everything the sample sees basically will find in the analysis. We have some residues from the syringe, we have some residue from the filter, and this is why it's important to really follow the instructions to the word, because before you sample, you rinse the syringe a few times with tank water, then you attach the filter to the syringe, and then you push the first 5 ml, you push into waste, and you don't collect it to flush the syringe filter. And then the rest of the syringe you put into your sample container and ship it to us. And what's important is that you, in contrast to ICP, like Organo-MS is a bit more time sensitive and also a bit more temperature sensitive. So it's if you can't send it away directly, then just put it in your fridge or freezer to keep temperature low. And also, as soon as the sample arrives at our facility, we cool it. If we can't measure it like directly, only if there is some lag time between arrival and measurement, we cool the sample, because some of the substances are a bit delicate and it might decompose over time.
And then another question I have with, you're looking at palytoxin, some of the other natural compounds that are emitted by dinoflagellants. Have you considered or gone into the literature in terms of what types of allelopathic compounds soft corals are producing or any corals for coral warfare are producing?
I mean, that's really an interesting field. There are some terpenoids that are known to be secreted by ladder corals, like as a signaling compound. But also for those class of compounds, I mean, this is a really niche field of research. So there is not a lot of data out there. There is some structures, and the moment we have like a structure and a molecular mass, we can start looking for it. But it's because those compounds usually are not in databases and have no references we can purchase. It's also for us quite difficult to include them. Yeah, but we are working on it. Yeah. The same is for coleopine, for example, like the alkaloid that's secreted by coleopter algae.
Yeah, that'd be interesting looking at all the different exudates from algae of different kinds. There's a lot of that's where like a lot of the DOC is evil research is right now. is
Yeah, I mean, with DOC or with the SAK 254, this was like the first look at the organics. But the problem with those sum parameters is that you can just say, okay, there is a lot of organics in there, or there is only a little organics in there, without any discrimination whatsoever. So there could be a lot of vitamins, but there could also be a lot of pesticides or paletoxin in there. So it's very important to have a method that can really discriminate between those different organics.
And then any other types of molecules of interest you're going to be trying to optimize or get results for, things you've thought about?
I mean, those dinoflagellate toxins are really top on the list because we expect to see them quite often. There is domoic acid, for example, which is sort of an amino acid, but is highly toxic at the same time. We're going to implement this one. And also with paletoxin, there is different variants like the ovatoxin, which is it's chemically related, but not the same. And there is very little literature about the behavior of this toxin. So those are the highest priority compounds to measure, at least like in a non-targeted way. And quantitation of those compounds will be a whole different story. Yeah.
What was the other question I had? So people that are carbon dosing, things like vodka, vinegar, is there like with the way you've set up the LCMS, are you able to detect acetic acid, any of the basic sugars?
No. I mean, acetic acid is just too small of a molecule. The same is like with ethanol. There is like gas chromatography, like the technique you've been using would be much better suited, like to measure those type of compounds. Also with the sugars, with carbohydrates in general, that's a really difficult topic because we like how the whole thing works. Yeah, we inject the sample onto a column, a separation column, and like on this column, the compounds like elute at different time points. And after the column, there comes the detector, which is this high resolution mass spectrometer that recognizes the compounds, fragments them, and recognizes them again. And with the carbohydrates, we have the problem that they don't really retain on this column, so they're just rushing through, and that's the reason why we can't really detect them. So we would need some, this would, at the moment, every sample we measure 4 times at the machine, like 4 runs with different scan modes, with different solvents and so on, to cover as much chemical space as possible. So the machine time for every sample is actually more than 1 hour.
Oh, wow.
And if we would need to add carbohydrates, this would add like at least another half an hour. And so we would, we couldn't keep the cost we are offering this analysis at the moment. But maybe in the future we'll find a way to make it fly efficiently.
Yeah, I was going to say you'd have to have like a much longer runtime on the column, wouldn't you? Or how would you get around that? I suppose would it just be? I didn't work with LCMS that much.
Yeah, you would need to basically the best thing would be to derivatize the sugars beforehand, to do some chemical modification to make them like more non-polar, to have like a later retention and also better ionization.
Got it. Yeah, that takes some time. That's a lot of processing on your end.
Yeah, sure. And if you look like at the commercial sector, where those we don't invented this type of analysis. This is LCMS is a technique that's common in pharmaceutical laboratories, in environmental testing laboratories, but it's a very expensive technique. Like the apparatus is very expensive to obtain and also to run, and you need a lot of, it's not something you put on your shelf and start measuring samples. You need a lot of method development and method optimization and to make it work a proper way. And now I lost track. A
lot of maintenance.
A lot of maintenance for sure as well. Yeah, but it hasn't been so bad until now. Yeah,
that's good.
But it's impossible really to cover all the compounds, and Yeah, this is I'm back on track again. When you buy this in a like commercial environmental lab, you're in a whole different price range. So I mean, it's more expensive than our ICP tests, but it's still, I think, affordable for the value you're getting and for the technique we are doing, because usually it would be like a multi-thousand dollar measurement.
Yeah. And then what's the resolution you're getting right now? Is it micrograms, nanograms per liter? Depend on the compound?
It depends very much of the compound, because they behave differently in the mass spec. But usually we are well below one microgram per liter for the limit of detection. Many compounds, it's like in the 2-digit nanogram per liter range. So that's
Definitely
pretty
sufficient for most things, I'd say. Yeah.
sufficient for most things. But I mean, for this really extremely highly toxic toxins, it's really important to have this low detection limits, because if you would be one order of magnitude higher with the detection limit, you might have some toxicity effects without finding it actually.
Do you think eventually you would upgrade to like an MS squared or something like that to get more resolution, or do you not see that as something that's really worth value?
We're doing MS square.
Oh, okay.
So we're doing this is like for the non-targeted section. We scan the product, so we have like an ion of the compound, then we fragment it, and then we scan it again.
Got
So
it. Okay.
yeah, and these fragments can be compared with databases. Yeah, so
Okay.
we get in this dimension. It's also the raw data of this Organo-MS is almost 1 GB per sample.
Oh
So
my God.
there is a lot of data in there, and this is really nothing you can evaluate like manually. It's like it's like needles in a multi-dimensional haystack. It's crazy. So you really need very specialized software to do the analysis for you. Otherwise, this doesn't work. But the nice thing is that in this full scan data, we have like the chemistry or the fingerprint preserved. So even, let's say, in like 1 year, we are finding out that a certain metabolite seems to play a crucial role in coral health. We can look at all the other data we acquired before and can still quantify this metabolite in this data, even we haven't been looking at it at this time.
That's going to be a game changer. That'll be great because, yes, things evolve. There's 10 people doing experiments with this. I'm sure that we will find a lot out very quickly, and it would be useful to draw from
Sure.
that sample size.
Yeah, I'm really open for ideas or for projects. So whenever you want to do something, just let me know.
Like I said, I've got probably 10. I got to think about the feasibility cost wise. I'll do the cheap ones first and then move up. Will probably be what I do. But yeah.
No, and regarding like those also the testosterone story, this is also something Andre posts on his Reef Moonshiner group, like this Organo-MS tales, where he interesting samples are highlighted to just show other reefers, okay, but what can be the outcome of this analysis and what's the consequences and the take-home messages, basically. Yeah.
Yeah. So let's talk about that. Let's talk about practical use for people. When would be good times to sample in your opinion? And how often do you think someone should be testing their tank with this method?
I mean, I would test promptly if there is some unexplained issues. If you are having some problems in your tank, it's really best to send off the Organo-MS and maybe send off the ICP-MS at the same time to cover like the whole spectrum of chemistry to resolve this issue. The Organo-MS, I think, is not a routine test like the standard ICP that one would conduct like every 4 or 6 or 8 weeks or something. I would get like a baseline reading when the tank is doing really well. And I would maybe do one every 6 months to one every 12 months, something like this, and the moment there is any issues.
And then what's the turnaround time to get the test sent in to getting your results?
Usually it's 7 to 9 days from the US.
Okay. And then what do they retail right now?
I think it's 89, 90 in the US in dollars. We are having here approximately the same price in euros. So I think that's not too bad. Yeah.
Yeah, it's not bad at all. I think it's definitely worth it. I mean, to see the whole, not whole, but like a much more accurate or full picture of the chemical makeup of your tank. That's $100. give or take with the tax and things. Every 6 months is probably worth the ease of mind, I'd say.
Yeah, and we also have this like sample collecting site at Reef Moonshiners. They collect the samples and ship them to us like twice a week using overnight express, and this is working really in a reliable way. And at the sample collecting point, there's also like a fridge where the Organo-MS samples, at the moment they arrive there, they're cooled as well. So we got the logistics figured out pretty well. So yeah, we've been doing this with the ICP tests like the last 2 or 3 years, and often it's crazy. Sometimes the turnaround from the United States is quicker than the turnaround from Germany, which is like a neighboring country of Austria here. So yeah,
that's crazy. Wow, I wonder why that is. That's pretty weird.
I mean, it's very good logistics at one side, and there is sometimes problems with the local carriers here that things get slowed down.
So it looks like a lot of work to be done with dinoflagellants and other toxins. Much more. The database will continue to expand with herbicides, pesticides, you name it. And it looks like the general solution right now is to add things like granular or catalytic activated carbon. And it costs $89, and you get 7 to 9 day turnaround time. That's sure. I feel like we've recapped it pretty well there. Anything else you would like to talk about while you have the spotlight today?
Whew. Oh, that's you've been asking me quick now. No, I think we covered like the most important aspects of this Organo-MS. I mean, it would be great if you check out our ICP service as well. We've really got a lot of data on reef to reef in terms of repeatability of detection limits, methods used. So we're a lab that's very open, I guess. We are not really a black box, and also people can write me emails and can call me up if they have some questions. And we're getting a lot of good feedback from the US, and I'm really happy about this. So thanks, Salem. It was great being on your show.
Yeah, thanks for coming on. I said thanks for having me on. Jeez, it's like you interviewed. Yeah, thanks for coming on. I appreciate it, and I appreciate you breaking the news with us. I'm excited to see what comes, and I'm excited to play with it.
Yeah, we were looking forward to your samples. Yeah.
All right. Well, thanks for coming on. If you want to check it out, go to reefmoonshiners.com to order this if you're in the United States. If you're not in the United States, you can go to Oceamo.com, I believe.
Exactly.
Is the correct website. And get your hands on an Organo-MS test today.
Whatever you want to call it.
All right. Thanks for tuning into this podcast today. It's brought to you by Cali Kid Corals, the ultimate coral experience. Be sure to like, subscribe, and tune in to the next one. Thanks.
Bye-bye, guys.